Hey, chemistry, did you enjoy those problems last night? Okay, I'm on page 418. You got your periodic table, you got your calculators, and you've got your paper and pencil. I told you yesterday that there's a difference between the concentration of a product and whether or not it's strong or weak. I forgot to tell you that, by the way. Well, this right here is vinegar. Can you consume vinegar like, in your salad? It's a weak acid, and you're going to learn about that later on. It has to do with the degree at which it ionizes. It breaks the hydrogen away from the molecule. Okay, when it ionizes in water. Okay, so it doesn't break that hydrogen off very easily. I mean, like, it likes to reform molecules. And so it isn't a very strong acid. Okay, but it's very dilute because this is only 5% water. Sorry, 5% acid, acetic acid, and 95% water. So when you buy this, you get mostly water. So it's very dilute. This is very concentrated acetic acid. It's called glacial because when it forms these little crystals that come out from under the cap, they look kind of bluish like a glacier in Alaska. And so they call it glacial acetic acid. It's 99.7% acetic acid, not 5% like this. 90, almost 100% acid. Very little water in here. So you would say that this is highly concentrated, but it's a weak acid. This is a dilute weak acid. This is a highly concentrated strong acid. It's hydrochloric acid. But if you water it down, let's go ahead and take just one little teeny tiny spit of this. Just a tiny little spit. And let's fill this whole thing up with water. Or better yet, get something bigger and fill it up with that much water. It's going to be pretty dilute, isn't it? But it's going to be very strong as an acid. Why? Because HCl breaks up into ions very easily, 100% ionizable. And you're going to find that out in a later chapter. But I just wanted you to know if there's a difference between strong versus concentrated. Concentrated versus weak. Concentrated and weak have to do with how much solute there is in a given amount of solvent. And then and the other is strong versus, I say concentrated versus dilute is how much solute there is in solvent. But strong versus weak has to do with the percent of ionization that the formula units or molecules undergo when they're making a solution. Okay, so what is molarity? Well, let's see if you know. I'm going to take some salt. Here we go. We're just going to go ahead and stick it on this balance right here. And we're going to tear out that little, right? There you go. 2 grams. It says 2.1, but I'm going to say 2 grams of salt. And let's find out. Put those salt grams right in this thing called a graduated cylinder. And let's put some water in there. I'm going to fill it to the top. Yeah. I'm going to fill it up to right there. That way it covered all the salt. And switch it around a little bit. I want to know how concentrated it is. Do you know when I mix my orange juice, I put the can of orange juice in the pitcher, and then I don't put 3 cans of water in there. I put more like 4 or 5 cans of water in there, make it real dilute because I like my orange juice dilute. Plus it makes the money go further. All right, so this is going to be dilute. I know because I only put a couple grams of salt in there. but it is 36 milliliters. 36 milliliters of what? Is it milliliters of solvent or milliliters of solution? Now the question is, does it have the salt in it or not? Yeah, it does. It's solution, not just the solvent. The solvent amount might not be 36, it might be 35.99, because it might rise up a little bit because of that salt. Anyway, you'll see that the formula calls for the volume of solution. So it's in 36 milliliters of solution. So now the question is, what's the molarity? Well, molarity is moles, which is the mass that I gave you, divided by the molar mass. That's moles, divided by liters of solution. So the mass I gave you was 2. Does anybody remember when we added it up? What is it? 23 for sodium, 35.5. What's 23 and 35.5? Well, let's see. It's about 58.5. And then the liters is, well, 36 milliliters. There are 1,000 milliliters in 1 liter. See, the 1 is the same as 1,000 millis. Milli is 1/1000th. Okay, so it's the same. Anyway, milliliters cancel. And you're going to get 36 divided by 1,000, which is 3 bunny hops to the left. So 3 bunny hops, 1, 2, 3, and it's 0.036 liters. So you put that right here. And so the molarity is going to be equal to that divided by that divided by that. So here we go. 2 divided by 58.5 divided by 0.036. You got to know how to do this, guys. Oh, I went further divided by that, divided by that, further divided by that. And that's 0.949. .95 molar sodium chloride solution. Easy capeasy. Now my question is, what if I add water? What if I add more water and bring it up to 72 milliliters? Is the concentration going to go up or is it going to go down? I'd say it's probably going to go down, less concentrated, because there's more water in it. You watered it down. Well, if you doubled this, isn't that going to become half? So that's 4, 7, 5 molar. Cool? Cool. All right, now the next question is there a maximum molarity for salt water solution? Is there a maximum molarity for a salt water solution? Well, now you got to go back to the previous deal. Look on page 410. Are you there? Page 410. What's the solubility for salt? What's the most amount of salt that you can get in 100 grams of water? Look at that table 4, dark green strip at the top. It's always based on 100 grams of water as a solvent. And so go across NaCl and down 20 degrees, that's room temperature-ish. It's 35.9. Let's call it 36 grams in 100 grams of water. 36 grams of salt and 100 milliliters of water which is going to weigh 100 grams because water's density is 1 gram per milliliter. So that is what we call the solubility. What does solubility mean? The maximum amount of solute that 100 grams of water solvent can hold. So if we use those numbers, then we'll know what the maximum concentration of salt is, salt water. The maximum concentration would be 36 divided by, what did we decide that was? Man, I can't remember it. 23 at 58.5. And then the number of liters is 1, 2, 3 bunny hops. And so there you go, that's it. So let's take our calculator and go 36 divided by 58.5 further divided by 0.1. That looks like 6.15 molar. That's the highest concentration that a saltwater solution can have. What if you had more than 100? What if you had more than 100 grams of water, more solvent? Then just do that. Let's say you got 200 grams of water. Well, now it'll hold 72. But when you double the top, you double the bottom, it's still going to end up being, that is the maximum molarity that you can have for salt. Okay, that's a nice discussion. The end. I'm just having you do more molarity problems tonight because you've got to know this. You've got to know how to plug that equation. See ya.